Solve this radical equation, where x is a real number. One way to solve this equation might be to remove the radicals by cubing the equation. However, the resulting equation might be very complicated. So we're trying to solve the equation using an alternative way. We notice that there are two radicals in the equation. One radicand is x minus 1, another radicand is x squared minus 2x plus 1. X squared minus 2x plus 1 can be written as x minus 1 all squared. Take the cube root of both sides of the equation. We know that a to the power of m, all to the power of n, can be written as a to the power of mn. By applying this, the right-hand side of the equation can be written as the cube root of x minus 1, all squared. Now we let y equal the cube root of x minus 1. Then x equals y cubed plus 1. Substitute x equals y cubed plus 1, in the original equation, we have y cubed plus 2 times y, plus 6 times y cubed plus 1, plus 11 times the cube root of y to the power of 6, minus 13, equals 0. Expand the equation, we have y to the power of 4, plus 2y, plus 6y cubed plus 6, plus 11y squared, minus 13, equals 0. Rearrange the equation, we have y to the power of 4, plus 6y cubed, plus 11y squared, plus 2y minus 7, equals 0. And we label this as equation 1. By substitution, the original equation is transformed into a quartic equation. It is easy to verify, using the rational root theorem, that the quartic equation has no rational roots. We will solve the equation using the factorization method. Assume that the quartic expression in the left-hand side of the equation can be factored into the product of two quadratic expressions, y squared plus ay minus 1, and y squared plus by plus 7. Note that, since the constant term of the quartic equation is negative 7, we try factoring it into quadratics, with constant terms negative 1 and 7, or alternatively 1 and negative 7. Here we try the former first. Label this as equation 2. Expand equation 2, we have y to the power of 4, plus a plus b times y cubed, plus ab plus 6 times y squared, plus 7a minus b times y, minus 7 equals 0. By comparing the coefficients of this equation with those of equation 1, we have a system of equations. A plus b equals 6. ab plus 6 equals 11. And 7a minus b equals 2. We label these as equations 3, 4, and 5, respectively. Add equation 3 to equation 5, we have 8a equals 8. So a equals 1. From equation 3, we know that b equals 6 minus 1, which is 5. So equation 2 can now be written as y squared plus y minus 1, times y squared plus 5y, plus 7, equals 0. The problem is divided into two cases. Case 1, y squared plus 5y, plus 7, equals 0. The discriminant of this quadratic equation is equal to 5 squared, minus 4 times 1, times 7, which is less than 0. So the quadratic equation has no real solutions. So this case is discarded. Case 2, y squared plus y minus 1, equals 0. So y equals negative 1, plus or minus root 5, over 2. As x equals y cubed plus 1. So to work out x, we need to work out y cubed. Y squared equals negative 1, plus or minus root 5, over 2, all squared. Which is equal to 6 minus or plus 2 root 5, over 4. Which is equal to 3 minus or plus root 5, over 2. Y cubed equals 3 minus or plus root 5, over 2, times negative 1, plus or minus root 5, over 2. Which is equal to negative 3, plus or minus 4 root 5, minus 5, over 4. Which is equal to negative 2, plus or minus root 5. So x equals negative 2, plus or minus root 5, plus 1, which is equal to negative 1, plus or minus root 5. Now verify whether they are solutions of the original equation. When x equals -1, plus or minus root 5, x plus 1 is equal to, plus or minus root 5. The cube root of, x minus 1, is equal to y, which is equal to, -1, plus or minus root 5, over 2. 6x equals 6 times -1, plus or minus root 5. 11 times the cube root of, x squared minus 2x plus 1, is equal to, 11y squared, which is equal to, 11 times 3 minus or plus root 5, over 2. Plus or minus root 5, times -1, plus or minus root 5, over 2, is equal to, minus or plus root 5 over 2, plus 5 over 2. 6 times -1, plus or minus root 5, is equal to, -6, plus or minus 6 root 5. 11 times 3 minus or plus root 5, over 2, is equal to, 33 over 2, minus or plus 11 root 5, over 2. Minus or plus root 5 over 2, plus or minus 6 root 5, minus or plus 11 root 5, over 2, equals 0. 5 over 2, minus 6, plus 33 over 2, equals 26 over 2, which is 13. Which is equal to, the right-hand side of the original equation. So x equals -1, plus or minus root 5, are solutions of the original equation.